Today we'll be focusing on the topic under kinematics, which is also known as linear motion. And the topic which we are going to focus on it's a topic so-called projectile motion. By definition, what is projectile motion? So projectile motion is basically the type of motion that involves the movement of an object in both x and y axis. In both y and x axis. So this is a motion that involves the movement of an object in both y and the x axis. Okay, so now let me give you an example on how objects moves. Okay, so I'll give an example. We have this object. I'll give it in the form of a bow. Okay, so a bow is being thrown. Okay, so we have this bow which is being thrown from here to there. Okay, so this bow is basically being thrown at an initial velocity, and that initial velocity is what we call the v naught. Okay, so it is called the v naught. So this is the v naught. So you say v naught. V naught, so meaning that the initial velocity. So this bow is being projected with an initial velocity, and where this are projected, it is forming an angle which is theta. Okay, so this bow is being thrown from point A, this is point A, to point B, and it is moving in both axes, which is the y axis and the x axis. Okay, so now this is the motion which involves where an object it is moving in both y and x axis. Okay, so now the distance from point A to point B is what we call the range. The distance from here to there is what we call the range. And the distance from here to there is what we call the maximum height, which is the h max. Okay, so if you have been asked to calculate the range, or I can say the maximum height, I'll start by writing the formula for the range. So the formula for the range is basically r equals v naught squared. Okay, so you square this one, sine. So since we know that it is the distance from here to there, so here we have theta. Again, we're going to have another theta there. So meaning that we have two angles. So you're going to say 2 times theta over the acceleration due to gravity. Since this bow, it is being projected here above the horizontal axis, which is this axis. Okay, it is being projected here at a certain angle, which is theta. Okay, so it is moving. Once you throw this bow, it will move from this point to point B. Okay, so when it is moving up, the acceleration due to gravity is negative, and when it is going down, the acceleration due to gravity is positive. So it will be over g. Okay, so this is the formula we use to calculate the range. Okay, so we'll be using this formula to calculate the range. Okay, so now let us look at the formula which we're going to use to find the h max, which is also known as the maximum height where an object reaches. So like I said, that this is the formula for calculating the range. So now let us write the formula for calculating the maximum height. So our diagram. And we have a bow here which is being projected above the horizontal axis, and it is moving in both axes, which is the x and y. Okay, so this bow is being projected with an initial velocity, which is the v naught. Okay, and it is oriented at a certain angle which is theta. So the distance from here to there is what we call the h max, which is also known as the maximum height. Okay, so to calculate the maximum height, we basically use this formula, which is h max is equal to v naught squared sine squared theta over what 2g. Okay, so since we know we have this gravity since we know that the ball is being projected here, so it is moving away from the gravity, and there is also another one. Okay, so we have this direction where the ball is moving away from the gravity, and we also have another direction where the ball is moving toward the gravity. So we're going to multiply the distance from here and from there. How many distances? We have the gravity, which is the upward gravity, or the one which is moving away from the gravity, and the one which is going toward the gravity. So we're going to multiply times 2. Okay, so that is the formula for finding or calculating the maximum height. Okay, so like I said that for the maximum height, we use the formula, which is this one. Let me change the color. Okay, so which is h max is equal to v naught squared sine squared theta over 2g. Okay, so this is for the maximum height. Okay, and kindly note that sine squared theta can also be written as sine theta squared. Okay, so now kindly take note. We can answer questions now. Let us look at our first example. We have the question which is saying that a baseball is thrown with an initial velocity of 8 meters per second at an angle of 30 degrees above the horizontal as shown in the diagram. How far does the ball move in the horizontal direction? Okay, so the movement of a ball in a horizontal direction is what we call the range. Okay, so the movement from point A to point B is what we call the range. Then the second question is asking us, what is the maximum height? So the maximum height is basically the vertical distance where the ball attain, or it is the maximum height the ball attain. Okay, so this is our maximum height, which is the h max. Like I said, the formula for calculating the range is equal to v naught squared sine 2 theta over g. Okay, then for the maximum height, which is h is equal to v naught squared sine squared theta over 2g. Okay, so this is the formula for the maximum height, and we also have another one for the range. Okay, to find the range. Okay, so for the range, like I said, that you use this formula. R equals v naught, which is the initial squared, sine 2 theta over g. Okay, and we know that acceleration due to gravity is basically which is 9.8. Okay, so you just plug in your values. We know that v naught, which is 80 meters per second, and our theta, which is equal to 30 degrees, our g, which is equal to 9.8 meters per second squared. So you just plug in the value. You're going to have our v naught, which is 80, so it will be 80 squared sine our theta, which is 30, so you say 2 times 30 over our g, which is 9.8. Okay, so our range will be equal to, once you do your calculation, you're going to find 565.55 meters. Okay, so this is our range. Kindly note that range is basically the horizontal distance between 2 points. Distance between the 2 points where the ball is being thrown and where the ball is going to fall. Okay, that is the range. So now we proceed to the next question. The next question, they're asking us to calculate the maximum height. Okay, so for the maximum height, since we know that maximum height is basically the h max, which is the maximum vertical point attained by a ball. Okay, So the distance from here to there is what we call the H. To there is what we call the H max, which is also known as the maximum height. So for the maximum height, we use the formula which is H is equal to V naught squared sine squared theta over 2g. Okay, so you're supposed to know these formulas by heart. Okay, so you say H, which is the H max, is equal to, you plug in the values. Our initial velocity, which is 80, so you say 80 squared sine, what is our theta? Our theta, which is 30, so you say sine 30 squared. Okay, sine 30 squared over 2 times gravity, which is 9.8. Okay, so you multiply. After doing your calculations, you're going to find our maximum height, which is the H max, be equal to 81.63 meters. Okay, so this is our H max, the maximum height attained by a ball, or I can say achieved by a ball. That is our maximum height, or the maximum point. The vertical point attained by a ball is what we call the maximum height, and horizontal distance is what we call the range. Horizontal distance is what we call the range. The vertical maximum point is what we call the H max, which is also known as the maximum height. Okay, so this is all about this class.